Hi बच्चों, so today we are going to do maths class 9th का the most important chapter circles जिसके basic terms हम last class में कर चुके हैं. Today we are going to focus on theorems. Now there are 12 theorems, out of which few theorems are really very important and they are given along with the proof in your textbook also. So we just do not have to remember and understand, but we have to prove also. So without wasting much time, let us start. Theorem number 10.1. Now what is theorem 10.1? See, it says equal chords of the circle subtend equal angles at the center. So what is given is equal chords. Equal chords have been given. And what is to be proved is that these two chords which are equal, they will subtend equal angle at the center. Let us start and assume this A and B are two given equal chords. So these two chords are given as equal. And now to prove, what is to be proved? We have to prove that these chords subtend equal angles at the center. So these two given angles are equal. That is what we have to prove in this theorem 10.1. So how to prove it? Let's do this. Now O is the center and we will connect A with O, C with O, B with O and D with O. So if we connect all these 4 points of the given two chords with the center, we get 4 radii of the same circle. So these radii being of the same circle are equal, right? They are equal because they are of the same circle. Now what we have to prove is these two triangles. So you just go back to chapter number triangles and think, if we prove these two triangles congruent, then it would be very easy by CPCT to prove these two angles also equal. So without much delay, let's start proof. So in triangle, now when we connect this, we get two triangles. In triangle AOB and triangle COD. So these are two triangles. Now we have been given AB is equal to CD because they are equal chords. Now OA is equal to OD and OB is equal to OC because they are radii of the same circle. Because they are radii of the same circle. Hence, these three are side, side and side. See, we are not taking any angle here. All three are given sides. So, we can say by SSS criterion, triangle AOB is congruent to triangle COD. So, these two triangles we have proved congruent, and if the triangles are congruent, then corresponding parts of the congruent triangles are always equal. So hence by CPCT, angle AOB is equal to angle COD, and this is what is required to be proved, right? This is the proof. They expect us to prove this part against this given theorem. I hope it is clear to you, right? Very quick recap. What we have done is, see students, you have to remember this, and in exam if they ask directly or indirectly, you are required to write the proof also. So we will make two triangles out of the two given chords by connecting the chords, the endpoint of the chords with the center. We are ready with two triangles. Now if we prove these two triangles congruent, then by CPCT angles are obviously going to be equal. So how to prove that? We have two chords and then all the 4 are radii. So all the 3 sides of triangle 1 are exactly same to the corresponding 3 sides of the second triangle. Hence the triangles are congruent, and by CPCT the angles are equal. I hope this is clear to you, and let us do theorem number 10.2. 10.2 says, if the angles subtended by the chords of the circle at the center are equal, then chords are equal. Now here we have been given that angles are given equal. And what we have to prove is the chords are equal is to be proved. So this 10.1 is exactly converged of theorem 10.2. this is 10.2, sorry, yeah. So this 10.2 is converge of theorem 10.1. So what we will do is, we will again keep the same two triangles, and here we have the angles equal. So what is given is angle AOB is equal to angle COD. Now this is given here in this case, and again by connecting the dots, the endpoints of the chord with the center, again we get four chords of the same circle, four radii of the same circle, and so these radii are going to be equal. Hence again we can use the same thing. OA is equal to OD and OB is equal to OC. We have to write reason. If we don't write reason, the teacher can very easily deduct marks. So radii of the same circle. Now this is one angle and these two are sides. Now observe one thing, these two sides are the radii, right? And this angle falls in between the two radii of one triangle. So respectively the other one also. Hence the angle given here is in between of the two given similar sides, and so this angle is known as inclusive angle, and thus we can say by SAS criterion, triangle AOB is congruent to triangle COD, and hence by CPCT the chords AB is equal to CD. So this is the proof of theorem 10.2. So here also we are using the same concept. The only thing is, earlier the chords were given equal and we were to prove angles. Now here in this case angles are given equal and we have to prove chords equal. Chaliye, so this is 10.2. Hope this is clear, and let's move to 10.3. Theorem says the perpendicular from the center of the circle to the chord bisects the chord. So there is a perpendicular. Perpendicular is given from where? From the center to a circle. So this perpendicular is given. OM is the perpendicular. If it is a perpendicular, then these two angles are bound to be 90 degrees. So this perpendicular is given and we have to prove that this line bisects the chord into equal parts. Bisects is of course dividing into two equal parts. So we have to prove AM is equal to MB. So how to prove that? Let's say we can see there are two triangles, triangle 1 and triangle 2. So here also we are going to use similarly, the way we used congruence in first two theorems, here also we have to use congruence. So we have two triangles here in triangle AOM and triangle BOM. Okay, what is given is it is perpendicular. So I can write angle OMA is equal to angle OMB given. Then we have OM is equal to OM. See, OM is equal to OM because that is a common side between both the triangles. It is common. OM lies in this triangle also and that triangle also. So it is bound to be equal. So reason is common. Please remember, reasons are mandatory. Okay. Now the third one is, see, because OA and OB are the two line segments from center to the end point of the chords, they are radii of the same circle and hence they are both equal. So OA is equal to OB. Right? Again, radii of the same circle. And so by RHS, see, this is RHS because this is a 90 degree angle. OM is one side and OA and OB are hypotenuse. So by RHS, triangle AOM is congruent to triangle BOM, and hence by CPCT these two sides AM and MB both are equal. So AM is equal to MB. I hope this is clear. We are only and only using congruence of the triangle. So there is no big deal. There is nothing difficult, no rocket science, and not much practice is also needed. If you understand it correctly, we have already done congruence in standard 7th. And in 9th standard also triangle has congruence, which is already done. So there are no difficulties in this proofs, right? So this was theorem 10.3. Now similarly 10.4 is also converge of the same theorem. It says that if a line drawn through the center of the circle to bisect a chord. So we are here talking about the same line through the center of the chord. So हम इसी line का बात कर रहे हैं. Right? We are talking about the same line, OM. Right? So if this is a line which passes line through the center of the circle to bisect the chord. Now this line is bisecting the chord AB into two equal parts. That is AM is equal to MB is already given to you. Then we have to prove that chords are same. Chord angles are same. That means they are both 90 degrees. Okay. So in the both triangle, so we have to, what is given is the line drawn through the center of the circle to bisect the chord is perpendicular to the chord. So bisector is given. Hence we can say AM is equal to MB. This is given. Right? And OM is equal to OM. So why? Again common. Now AO and BO, right? AO is equal to BO because they are radii of the same circle. Correct? So now we have all the three sides again. See, bisector, common side and radii. So this is again by SSS, triangle AOM is congruent to triangle BOM, and hence angle OMA is equal to angle OMB by CPCT. So this is required to be proved. So this is proof of, so these two are similar angles. So both are same. Now one thing is left here. They are same is okay. But we have to prove that this AMB is a straight line. Now because it is already given AB is a chord, so hence AMB is also a straight line. AB is a straight line, so AMB is also a straight line. And if it is a straight line, then the total is 180. Now if there are two angles and the total is 180, then obviously the angles are 90 degrees, right? So both the angles are perpendicular. I hope this is clear to all of you, and see you in the next class where we are going to take the theorems ahead. See you soon.